Hello guys, today we're going to study 2.2 more on functions and their graphs. So first let's take a look at increasing, decreasing, and constant. If you think about increasing, this is talking about interval, okay? You can think about, someone gets sick, or when you get sick, nighttime, most likely your temperature is going to increase. And then during the day you get a little bit better, and then it's decreasing, and then sometimes it's a constant, there's no change during this interval, okay? Interval, you can think about, let's say from 10 o'clock to 12 o'clock, something like that. So here we have a formal definition. You can pause the video, go ahead and take a look. So we have example 1, intervals on which a function increase, decrease, or is constant, okay? So read the question carefully. State the interval on which each given function is increasing, decreasing, or constant. So if we look at this graph, okay, let's look from the left to the right. So here, if this look at this graph, is clearly this going down. So here, this is going down. That means it's pretty clear. That means it's decreasing. All right, and then you go ahead going up, right? That means it's increasing, and then from this point right here again, that goes decreasing, right? Because that going down. So this is increasing this portion. So how we can answer this question? So for part A, so we're gonna write the interval form, okay? So if you look at this graph, we already know, we just talk about this portion is decreasing, right? So if you look at here, that goes on forever, right? So if I want to write it out, it goes on forever. So always, when you look at this, now you're going to look at x-axis, all right? So your corresponding x-axis, that will be, go on forever, that will be negative infinity to this point right here. So since here I can't really draw a line, so I know it's going to be until from this portion, okay? So that means negative infinity to 0, okay? We're always going to use a parenthesis because we can't include this 0, because right here at the 0, exact 0, there's no increase or decrease, right? Because that is a 1 point. Or you can just memorize it. For increasing and decreasing questions, there's always a parenthesis. There's no bracket involved here. So it's different than the domain range. It's a different type of question. Okay, so then from 0, we increasing on the interval from 0 to 2. Because if I write this line, let me see if I can change the color. I'll use a pink. So basically what we did is from here, okay, because from here and then until this portion, if you look at the interval, we have to look at x-axis. So your graph starts 0 and then 2. So from 2, decreasing on the interval. Now we're looking from here, from 2, and then if you look at this, extend it out, right? So that means it's going right side forever. That means from 2 to the positive infinity. So for part B, look again. So we're going to start looking from the left side. Okay, if you look at this line, that doesn't change, right? So again, we're just write down the interval, so constant. So from here, this side to go on forever, that means it's negative infinity. And then we're to the point, so this is 0. Remember, we're dealing with this type of question. You don't have to use a bracket. Okay, there's always going to use a parenthesis. And then from here, this is pretty obvious. So we're going up. That means it's increasing. And then the increasing corresponding from here to this line obviously go on forever. There's no end to this side. So let me see if I can go ahead and graph it. So because this is increasing, and then I'm corresponding the x-axis. So which means I'm going to start here, going this side forever, right? So that's why we're going to have increasing. So that will be from 0 to positive infinity. For this type of question, you always use parentheses. You do not use the bracket. So it's different than the domain range. Let's look at the definition of relative maximum and the relative minimum. Please pause this video and then go ahead and read this. The easiest way to remember is just look at the graph. Okay, so we have relative maximum. If you look right here, that is the relative maximum from this graph. Perhaps you can read the formal definition, but we don't need to have to prove anything. We're just going to learn how to use it. So this point is the relative minimum. So here we have an example. I'm giving you a graph. All right, so if a graph, a function is given, which is on the left side, so we often visually locate the number at which the function has a relative maximum or relative minimum. For example, okay, so in this case, it's really straightforward because it's a graph. This already gave you the relative maximum, and here we have a relative minimum. So we say f has a relative maximum at, so we'll look at this point. This point is a pi over 2, 1. That is our ordered pair. So for this type of question, when you ask f has a relative maximum at, we're going to say that is your x value. So maybe I'll highlight this. And then the relative maximum is, that just means if you plug this x inside your function, you're going to have your y. Or you can think this is just the answer. The relative maximum is 1. Maximum is, that's just your y value. That's where those come from. Okay, then we're doing the same thing. F has a relative minimum at, alright, now we look at this minimum, so our x value is just going to be negative pi over 2. Okay, relative minimum is, that just your y value, which is negative 1. Okay, or I can write this is f of negative pi over 2 give you negative 1. Okay, because you plug in your x in the function, that just give you a y value. That's how we find them. Okay, now we're going to study definition of even and odd function. Okay, this is very important. You're going to see this stuff a lot. So when we talk about even function, the main part you need to remember is, go ahead and highlight it, is this portion. Okay, even function, when we talk about even function, so that means f of negative x must be f of x. Okay, and then our even function, if we're going to have an even function, that implies you're going to have a y-axis symmetry. Okay, a typical example that will be something like this. Okay, when they talk about this y-axis symmetry, you just have to think the y-axis like your mirror. Okay, so if I'm going to fold this, or you can think about origami, if I fold this, that will be overlapping. Okay, fold this from the left to the right, that will be overlapping. Or you can think about if a person stands this side, okay, that's your mirror, and then reflection exactly the same distance. Okay, that is the even function. So even function means the y-axis symmetry. And then the second one is the odd function. So for odd function, you must remember this. That means f of negative x equal to negative f of x. Okay, that also means it's origin symmetry. So typical example like this. So that is origin symmetry, which means if I'm going to start right here, I'm going to twist this, okay, 360, you're going to come back exactly the same, just like the clock. Okay, if I twist this 360 degree, then I'm going to come back exactly matching. That means it's origin symmetry. Alright, g of x equal to x to the third power. Okay, so you need to know this. You need to memorize this stuff. Okay, you're going to use this a lot. So here we have an example. Identify an even or odd function. So I have a f of x equal to x to the third power minus 6x. This is the formula. I'm just going to write it on the side, so that way you can know what to do. So anytime they give you something like this, all you have to do is just evaluate f of negative x. Okay? We did some example in 2.1. When you have negative x, that means anything inside this parenthesis. Okay, we said just like you evaluate f of 2, you just plug a 2 for every x you see. Once we have this, we're going to simplify a little bit. So since it's a negative number raised to a odd power, that means I'm going to have a negative x to the third power. You can think of this as negative 1 to the third power. That will give you negative 1. That's where that comes from. Okay, and then here that will be plus 6x. Alright, so I'm going to rewrite this. F of negative x equal to negative x third power plus 6x. So now I have this. Alright, so I'm going to compare. So I'm going to compare to f of x. Because if they match, that means I'm going to have an even function. This is clearly they're not matching, right? So here we have x to the third power. Here we have negative x to the third power. So I'm going to write because f of negative x is not equal to f of x, it's not even function. Now I have to check about odd function. So since it didn't work, I'm going to check the next. So how can we check the odd function? I have to plug in a negative sign from your function. Okay, my function is right here. F of x is the x to the third power minus 6x. So if I put a negative sign from your f of x, so I'm changing a different color. Okay, if I put a negative sign in front, I'm just going to put a negative sign right there, and then I'm going to put a parenthesis. So everything else, I'm just going to copy it down. That will be x to the third power minus 6x. Okay, again, all I did is I'm going to follow this negative f of x because I want to compare this to f of negative x. That is the reason. Okay, I plug in negative from your function. So I use the green color. So now I'm simplified it a little bit. That will be negative x to the third power plus 6x. So again, this whole thing is just going to be negative f of x. Okay, so now we have negative f of x, and then I'm going to compare. Look at this odd function. The definition want me to compare f of negative x. So now I'm going to compare those two. So I look at this function, and here they are a match. So I realize f of negative x is equal to negative f of x. Because of this, I'm going to say it's a odd function. Again, it's very important to show work. Part B, we have g of x equal to x to the fourth power minus 2 times x squared. So anytime you have a question like this, first thing you're going to do is you're going to plug in negative x for every x you see. So there's going to be negative x to the fourth power minus 2 times negative x to the second power. Okay, all I'm doing is do substitution. So once we have this, we'll simplify a little bit. Negative x to the fourth power, this whole thing raised to a even function. That means you're going to have x to the fourth power. So here again, negative x raised to an even power. That means you're going to have x squared. So now I'm going to compare those two. I'm going to see if they are same. I look, they are actually same. So I say that g of negative x equal to g of x because of this. And then this whole thing give me a even function. Part C, we have h of x equal to x squared plus 2x plus 1. Again, all you have to do is you start with plug in negative x. Alright, you evaluate h of negative x. So I'm going to put this inside. Alright, for every x I see, I'm going to replace with negative x and then plus 1. So this is going to become x squared, and then here we're going to have minus 2x and then plus 1. Once we have this, I'm going to compare those two. Right, again is a compare. So I look here, alright, and the h of negative x, clearly they're not same because the positive 2x and negative 2x. So this means not even. So we got to continue. Now we have to figure out what is negative h of x. Okay, earlier we used the green color for this negative sign. Do you remember? Okay, all you have to do is just put a negative sign from this whole thing right here. That will be x squared plus 2x plus 1. Again, you need to put this big parenthesis right there. Okay, otherwise the whole thing is going to get wrong. So I just put a negative sign right there. That will be negative x squared minus 2x and then minus 1. Now we're going to use this compare here, because I want to use the definition right here. Okay, see if they are same. So I compare them, then I realize they are not same, right? Because here the sign, we have negative x squared, here we have positive x squared. Also it's positive 1, negative 1, so this means not odd. So since we're not even, also we're not odd, so the answer is neither. That is your final answer. So again, for this type of question, you're going to see a lot in the future. You must learn how to show work. If you still struggle, make sure to ask me for help. If you do not show work, you won't get any points. Thank you for watching the video. I'll see you guys next time.